Hi, this is Lex, and welcome to the Fintech Blueprint. It's your podcast about fintech, decentralized finance, digital banking, investing, robo-advice, artificial intelligence, and all the other frontier technology that is transforming financial services. To get more content, like an illustrated transcript of this conversation in your inbox, subscribe at fintechblueprint.com. So without further delay, let's jump into today's episode. Hi, everybody, and welcome to today's conversation. I'm so pleased to have with us today Stephen Balavan, who's the CEO at Lambda Labs. Lambda is an artificial intelligence company, and we'll talk about that industry and the different parts of the industry and how they've evolved. A bit of disclosure, I've known Stephen for a while, and it was actually one of my first angel investments. And so I have an immense conflict of interest as well as a personal interest in everything that Stephen's been doing and Lambda's been doing. So with that out of the way, Stephen, welcome to the podcast.
Hey, Lex, thank you so much for having me on. This is cool.
So before we get to the meat of Lambda, what it does, and kind of AI and the present, let's talk about you at the very beginning. In your background, it was like education and then immediately neural networks, which is unusual. Can you talk about sort of your academic training, like what you were doing, and then how was it that you got pulled into this direction, when you got pulled in this direction, and what about it resonated with you?
I studied computer science and economics at University of Michigan. I think like a lot of people who are into computers, you read about artificial intelligence in science fiction, whether it's maybe one of my first exposures to it, I can remember is reading Neuromancer by William Gibson. And that sort of really has a very interesting perspective on how AI interacts in the world. And, I sort of, the way that I got into deep learning and sort of like really got into, I guess, AI in the newer sort of, the latest, I guess, incarnation of it is actually through face recognition software. And so I ended up sort of diving into this problem of like, how do you recognize faces in an image? And what you find out is that this is like kind of like a largely an unsolved problem. I really was interested in this idea of how do you make it so that you can walk through the world and like sort of, like if you've ever played World of Warcraft, in World of Warcraft, everyone's name and their sort of guild is underneath their name. And, I wanted that kind of overlay on the real world. And so that's how I sort of got into face recognition as a general thing.
I want to take this in two directions. One is the technical skill set that's required to even approach AI-based image recognition and all that. But before, I want to like splash around in science fiction and these waves of investment into artificial intelligence. Neuromancer, what is Neuromancer about? And, what stuck out to you about it? Maybe like we can even place that in the context of how people had thought about robots and how that's changed.
One of my professors at Michigan actually had a really interesting perspective, which is they said, one of the interesting things about science fiction is that, you can read it and get inspiration for sort of like what to build in the world and maybe how the world could be. And, it's maybe some combination. It's like a reading science fiction version of Alan Kay's quote, which is, if you want to predict the future, the best way to predict the future is to invent it. That really resonated with me. And so, I'd read Neuromancer as a kid growing up. And, of course, I'd seen 2001: A Space Odyssey, which is another famous sort of both book and obviously Kubrick film where, they sort of look into human evolution. And, artificial intelligence is almost like a capstone on human evolution in 2001 in that universe. As far as Neuromancer's sort of maybe even one of the first books to really explore, I guess, cyberpunk as a general concept, which is, high technology, low life. That's like that's the one sentence summary of cyberpunk, right, as a genre. And, William Gibson really does an interesting job of exploring sort of this concept of artificial intelligences that are sort of quasi-controlled by this off-world family, I think the Tessier-Ashpool family. in the world. And, the way that AIs interact with humans is they're almost like demigods, they have this sort of unlimited power. It's unclear what their motives are, but they are, influence the world in some way. And I thought that's an interesting, it's an interesting alternative way of looking at AI versus maybe the Asimov style, like iRobot, which is a little bit more grounded in AI being like a machine that can think. Gibson's version was pretty abstract.
A few years back, I went on a science fiction reading binge where I tried to get like the book from every decade. Roughly, it was Asimov, and then it was Dune. And after Dune, I think I did Neuromancer. For the 90s, I did Diamond Age.
Yeah, Diamond Age is another great one.
Yeah, for sure. And then in the 2000s, it was this book, Accelerando, which has really imprinted on me and informed actually a lot of some of my career choices too. Neuromancer was also like the place where cyberspace was probably first articulated as this, like metaversal kind of space.
Snow Crash is another good one too, maybe to throw in there for a 90s Neil Stephenson. Snow Crash. Of course, I guess you already got Diamond Age, but that was also another great cyberpunk one.
These are all fantastic. And I think what they all do is they paint the future with magical technology present. But then simultaneously with that, there was real world technology and math trying to do AI. And the math for like deep learning and neural networks and all this stuff had been, as I understand it, like derived in part by Turing and others in the 50s and 60s, and it was funded 3 times through 3 different kind of investment booms and busts, and nothing had really come out of it despite all these attempts and all of this sophisticated mathematics. So when you were working on Perceptio and you were working on sort of facial recognition, were you aware of the history and like what was your concept of what had already been done, I guess, in the past?
Yeah, no, very much so. I was definitely very aware of the history. I definitely try and do my best to read about business history, technology history, and so was familiar that there was an AI boom in the 80s and a subsequent AI winter. When I was at school in Michigan, it was really clear. They did the standard thing where they show you what a perceptron is, and they show you that a perceptron is unable to learn a very basic function XOR. Right. And that's like sort of one of, if you will, like sort of, I guess you'd say the death knell paper for AI for a while. I don't know when the original paper was published that sort of like killed perceptrons or whatever, but like, they really just emphasize that there's some limits to that architecture.
Can you frame that a little bit more just in basic definitions? Like, so definitely what is a perceptron and how does it fail? But then outside of that, like what is an architecture in the first place?
I want to say that like specifically the thing that I'm talking about, I forget what the actual paper was. I think it was Marvin Minsky who published the paper with a lot of criticism about Rosenblatt's perceptron. The basic idea though is that, this was a very limited architecture for a neural network and was not able to solve that basic problem of learning the XOR function. And because of that, I think even Marvin Minsky, who's one of like, I'd say the original like fathers of AI, one of them, right, kind of maybe even had some regrets about like how much damage that paper did to the industry in a sense, like maybe discouraging further research into these types of architectures. I mean, like going back to the history, one of the things I was doing in like 2013, I remember reading through some of the emails I think that Jan LeCun had written back when he was at Bell Labs and, doing research. And it was just so interesting because, deep learning was having this renaissance. DeepMind was formed and was, acquired by Google. Jeff Hinton and researchers were selling their company to Google. And, in 2012, 2013, deep learning specifically was having this renaissance. And it was just interesting to read these emails from Jan LeCun in like the 80s. I want to say it was like late 80s or early 90s. Jan LeCun had been working on similar architectures that really worked in the 80s and 90s. And it was just really a matter of putting more computation behind it before we started to see progress again.
Yeah, I think this point is just so wild to me. It's profoundly affecting this period from 2012 to 2014, where the Stanford competition for image recognition, like the error rates on telling a cat apart from a dog went from 10 to 8 to 6 to 4, with 4% being better than the human error rate of recognizing an object. And so you had this moment where the machine is better at seeing in a way that obviously isn't connected to consciousness or to the rendering of some object or description of the object, just the process of identifying a visual perception and mapping it into the concept space. Like, it was doing that better than a human being. I mean, after decades and decades and decades of people saying this thing's not going to work, and even, as you say, kind of the leaders of the space giving up on it, and yet you decided to build in this space. So what happened?
Interesting, like sort of like going back to sort of even science fiction and being a little bit of an inspiration is that, so in 2012, I was really interested in this problem, like I was saying, of having this sort of visual overlay in the world. It was a little bit like sort of, an augmented reality type of vision where it'd be some combination of, basically glasses that you would wear that would overlay information about the world, and it would be tied into an artificial intelligence that would be able to, recognize faces, tell people. It kind of be like a serendipity accelerator, right? The idea was basically you could meet somebody on the street and it would tell you all the social connections you had in common, maybe, little facts about each other that were shared interests or whatever.
These days, this is like the Chinese dystopian imagery. Like, whenever you read an article about how tough it is in China, like you get the image of people's faces and squares
and
with
social
like
credit scores above their heads or whatever. But there was this really great anime. There's two great animes that have been pretty inspirational for me. One is Serial Experiments Lane, and the other one is Den-O Coil. And Den-O Coil is about a future where the first generation of children who grow up with basically smart augmented reality glasses. Basically, I really wanted to build that thing. So if you go watch the anime Den-O Coil, DENNOU Coil, COIL, basically they have these like little, sort of pets inside of augmented reality, and they can sort of play in this totally separate world that's layered on top of the real one. And, that's how I got into this original problem. I was like, okay, well, with that, you need to have really good face recognition. Obviously, it's like a primitive in building a good augmented reality system. And I realized that face recognition problem was really an unsolved problem. And thankfully, at the time in 2012, like Alex Kershevsky and Ilya Sutskever had just published the ImageNet paper where they had trained, a state-of-the-art ImageNet on basically a desktop computer underneath their desk. And, that had top performance on ImageNet and was, again, being compared to, I think Google at the time had a similar paper, which is, I think I call the cat face paper. I forget. I want to say it's Andrew Ng worked on that paper, but they trained it, Google trained a network that did well on ImageNet with 19,000 CPUs. And then Alex and Ilya did it with a couple of GPUs under their desk. And so, at the time, face recognition has always been this extremely competitive field in terms of like technological ability, like the NIST. So the National Institute of Standards and Technology had the Ferret competition, which is, I think, FERET, which is a face recognition competition. And the cool thing was that like around that time, all the state-of-the-art people were doing deep neural networks to, have state-of-the-art face recognition performance. And so it sort of fortuitously, it was really lucky for me to just kind of get piped into the deep learning community just because I was trying to solve this face recognition problem. And so that's like really the origin of me getting involved with deep learning. You mentioned Perceptio. I don't think anyone in the audience had like heard of this part of the story, but, I joined this company Perceptio as basically their first employee. We were doing image and face recognition software that ran locally on the mobile phone. And Perceptio, we basically were running neural networks that would, the inference pipeline was actually with OpenGL ES shaders. So it was like OpenGL, like gaming shaders, like computer graphics shaders, but to actually run the neural network. That company ended up getting acquired by Apple. And, some of that technology eventually got integrated into iOS in the form of the kind of face and image search features that you see today.
For context, it's also important to say that this is a decade ago.
That was in 2013. It just ended up being sort of lucky that face recognition was so well solved by basically convolutional neural networks at the time. Interestingly enough, the path for Lambda is this like really crazy, insane path. But in 2013, Face.com, which was this Israeli company run by Gil Hirsch and a few other people, Face.com was acquired by Facebook. Face.com was doing face recognition software, and that's what eventually got Facebook, to add the auto tag feature. When they got acquired, I kind of knew that they were going to shut down their API. And that's actually how Lambda first launched our first product. Our first product was a face recognition API. And we launched it in 2012-ish. And that was sort of the beginning of the whole thing for me.
I had a strange entry into the space as well and reaching out to you around that time because I was focused on the automation, the straight sort of digital transformation of the investing industry. As an entrepreneur, you sort of absorb these stories you tell to the world of like the introduction of technology, of like this advanced technology into the space is going to be so fantastic and it's going to democratize access and it will be cheaper for everyone. And now, everyone can have better versions of financial services or healthcare, whatever you're focused on. And then at some point between 2012 and 2014, the AI stuff had kind of turned into DeepDream. And I'm sure we'll talk about that in a second. I'll ask you kind of to define DeepDream and DeepStyle and what these things were. But all of a sudden, you started having these applications of math to the visual arts. And of course, today with Dall-E and generative AI, this stuff is so vividly better than anything a person on average would do. In the moment, you could see that kind of like seed being planted where the hallucinations of machines were generating more interesting visual outcomes than artists and potentially incredibly novel outcomes. And for me, like I'd been spending all this time being like, technology is going to be so good at replacing financial advisors. You just use a robot to move your money around. And then like in my private life where I had an arts practice, it was basically a holy shit moment for me because I was like, these robots are better artists than anything I can do. And that made me feel like profoundly affected. And I remember finding the application you were working on at the time and reaching out to you. And this is a good place to kind of ask, what was that application? What is DeepStyle? And kind of how did you get there?
Yeah. So anyone who's done face or image recognition before, loves looking at the weights of their neural network, like visualizing the weights that are being learned by a ConvNet or by a neural network are an important part of understanding how well the learning process is going. And so it's not uncommon for people to sort of plot out visually what the weights are and the convolutional filters that are being learned. And they're really beautiful. Like anybody who's been doing that work will look at their weights of especially if you're learning a visual neural network, right? You're going to look at those weights and go, wow, I can see, this is a feature that's learns to detect glasses. This is a feature that's learning to detect whether somebody is older or younger. And you can kind of see the different features that are being learned by the network. Sometime in, I think it was like summer of 2014. I want to say it was 2014 or was it 2015? It's a little bit blurry for me. I think it was 2014. We saw the first image that was created by DeepDream and it came out of Google. It was this sort of like slug-like squirrel. It was a picture of a squirrel that was like something you'd never seen before. It was very trippy, very psychedelic. And the first moment I saw it, I was like, wow, what is this? This is strange. Because I knew it was I could tell it just looked like the type of images that you might see generated. You might see sometimes when you're looking at your weights. And I was like, okay, this must be coming from, it's coming from the Google Brain team. And that really kicked off the beginning of what I'd say is like the current modern era of like generative images and generative artwork. What the team at Google Brain found out is that if you just basically change the image, it's interesting. Basically what they did was they're doing like this sort of what's called L2 maximization. Basically, you run a neural network and have it look at an image, right? And then it'll say sort of what it sees. And then you sort of augment, you say, hey, see more of what you're already seeing and less of the things that you don't think it is. So for example, if it looks at a squirrel and it sees a squirrel or sees a slug or sees other things, you're going to sort of bump up the features that are really salient, and you're going to diminish the features that are not salient. And then you run backprop and you backpropagate through the network down to the data layer. And usually you run backprop to update the weights of a neural network. But actually with the DeepDream, what you're doing is you're backpropping back to the data layer, and then you're actually updating the data itself. So it's kind of an interesting use of a neural network. You're not updating the weights of the neural network. You're instead updating the actual input and changing the input data. They were able to do things like, if you chose features at the very semantic level, you might be able to hallucinate things that don't exist. And if you chose layers that were, if you will, like earlier in the visual cortex of the network, meaning like, edge detectors, line detectors, stuff like that, it would actually kind of give you this almost Picasso or like impressionistic style. You know what I mean? I don't know if you remember the first DeepDreams.
It made my skin crawl at the time, was just that like squirrel slug pug dog.
Puppy slug.
Like I've seen those on hallucinogenics in college, right? Like I've seen exactly that. Like what it reflected to me wasn't like a magic quality about the tech. It was that we were reverse engineering like perception.
Perception. Yeah, no, I mean, it definitely says something when there's a marked similarity to psychedelic experiences. I mean, and when you take it to the extreme, it's like, on one hand, if you go very high up in the semantic layers, it's like a DMT trip, like insane like structure and color. And then if you go lower in the layers, it's almost like, this sort of, Van Gogh style impressionism. And it's just very interesting, what you learn maybe about perception in general when you study these things.
Yeah, this is why like all the Chomsky pushback about like AI not being intelligent isn't interesting to me at all, because you don't need to understand what you're perceiving to like see if your artificial eye works, But anyway, maybe if we can go from that to how the DeepDream algo innovated on top of that, what did it mean to pull in style inputs? And then how did you end up setting up DreamScope, and what was that like?
We saw this, and we knew immediately that people were going to want to generate images like this. And so we just sort of like rushed to develop an application. We had a web app that we launched called DreamScope. It was dreamscopeapp.com. And then we had an iOS app that we quickly followed on with. And we launched it, and we were processing millions and millions of images within the first couple of weeks of launching. And I would say that if you saw a DeepDream image during that time period, it was very likely that it was generated by DreamScope. I mean, we were by far and away the most popular DeepDream generation application. And then in August, I believe, of 2015, Leon Gatte's and, Gatte's et al. 2015, which is the paper of neural style transfer, came out. And that was actually taking it one step further. So instead of just hallucinating stuff, you can basically say, here's the base image, here's a target style image. And then it would use this gram matrix representation, which was basically sort of like a covariance matrix as part of the optimization. And you could basically take an input image and reimagine it in any style that you can think of. And that was also very popular. And what ended up happening was, this is 2015, 2016. This is the early days of what, we call maybe at the time neural style transfer. There was a company called Prisma that we competed with at the time. And it was interesting because, they've also, gone on to, they made Lensa. So Prisma is the company behind Lensa.
I was going to ask you about this, and maybe I'll ask you now before we get into the hardware stuff, because your vantage point on it is so interesting. Do you look at Lensa and you're like, oh, I missed that one? Or
no, it's interesting because, of course we used to compete with them, and it's fun. It's like really engaging to find a company that you compete with, and like, we're both like really working really hard to build the best product. And it's just fun to have competition, I think, sometimes. And when I look at them now, though, it's funny because we're now in the infrastructure space. So now we're on the side where we're we're providing workstations or servers, and we have a cloud service now. And now I get to approach them and say, hey, are you interested in some of our cloud service, our GPU cloud service, for example? So I don't have any feelings really about it other than that. I think this is an interesting segue. So, what actually happened was DreamScope was doing really well, but we had this really expensive cloud bill. It was a really, really expensive AWS bill. It was around $40,000 a month or something. And one of our early investors named George, who led our Series A and was an early employee at Google, said, hey, you should just build your own infrastructure. And so we did like a $60,000 CapEx and replaced our entire AWS GPU bill with just, running our own infrastructure. Actually, it was like in a garage in Portola Valley. It was actually the offices of another one of our angel investors, Austin Russell. And we're basically, so Austin was running Luminar, which is now a public LiDAR technology company and autonomy company. We basically ran this little like data center out of that garage in Portola Valley. And that's how we got into the deep learning infrastructure business. Like, we're like, oh, wow, we're saving a ton of money by running our own infrastructure. We're pretty good at this. So let's do this for other companies. And it's actually because of DreamScope that we got into the business of providing deep learning infrastructure. And so we started selling workstations and servers and eventually launched our own cloud service. And so we completely pivoted the company. And, sad to say, but, we maybe last year shut DreamScope down. But it's okay. We've built a great business on the infrastructure side now.
Yeah, absolutely. I want to, just because I think it makes sense in the conversation, to double click first on the evolution of the AI algorithms, right? So like this period from 2011 to maybe like 2017 was this like deep learning period, the convolutional neural network period. You had some adversarial stuff going on, right? Where it was like these big data sets, like all your financial transactions at JP Morgan, or like, all your health data or whatever, all these images of cats that we gave you. They were large data sets, but they were still sort of they weren't the whole internet. More recently, with OpenAI, there's been a step function in the nature of the algorithms that are being used. Like looking at Lensa, like it is a million times improvement over the deep style tech that their prior iteration provided. So can you talk about what's the advance in the AI math and like what has enabled that to happen?
The number one thing is, of course, the transformer architecture. And, that's been, I think the main step function seems to be the scaling up of transformers, basically. Previously, you had these generative networks were basically, constructed out of convnets, which are neural networks that are designed to recognize images. And so they're shown a bunch of images. And the sort of current generation of like, whether it's Midjourney or a Dall-E or whatever, these are actually sort of networks that are jointly trained with both images as well as text, right? So they have an understanding of the semantics of, the English language and other languages. And those models are much more powerful. They obviously before the only way that you could sort of communicate, quote unquote, with the neural network or with the AI is to like show it a source image, show it a style image, and then do something, with those. But now, with transformers and large language models becoming a part of that architecture, you can now actually type in text. Of course, you can still give it a source image, but you can also now type in text, and like that's a much more rich interface into how you might want to generate images, basically.
I have a very loose, non-technical map of it, but like I kind of think of it as on the one side, you have a model that has ingested not a local data set, but like the entire internet. So all of human intelligence of a particular type, like visual or language, and flattens it out into some sort of multidimensional space where like it can interpolate between a picture of a cat and a dog and find every infinite sort of permutation of that. And then you can add a little bit of like in the style of 3D rendering or Pixar or, in the style of a movie from 1985 or something like that. And so there's like this flat space of all images ever. And then on the other side, you've got this other model, which has done the same thing for language, like ingested all language ever and flattened it into this other space. And you can use one to navigate the other. And so you're giving people controls to like float around, like going back to Neuromancer, really float around in cyberspace where the stuff in that space, in the latent space.
Yeah, in neural latent space, right?
Exactly. Is totally wild.
I stopped basically, we've never trained, for Dreamscope, any of the modern sort of Dall-E style clones or stable diffusion or whatever, right? And so I too am like, that's outside of my field of expertise. I did a lot of stuff with neural style transfer back in the day and did a lot of stuff with face and image recognition back in the day. And so like, I'm also not even, the right technical expert there. I mean, I know a little bit about it, but I'm not, by any means a technical expert on things like some of the newer architectures like Dall-E. It's interesting, you talk about the latent space stuff. It's like, all of these things have a latent space to explore and to go around. And so like that's definitely not a new concept in terms of these large language models. I mean, you could always explore around latent space with some of the older stuff too, but certainly it's gotten a lot better with the addition of language into the mix.
Let's put the spotlight on the company that you're running and, like the bet that you made to transition out of the consumer social network sort of art use case and into the realization that more and more entities, whether they're enterprises or individuals or developers or whatever, are going to need to be able to run these really complex AI focused, I don't even know what they are, let's say algorithms. How has that bet gone? What are the things that you want to share about it? And sort of like, what's the pace been like? Like, have you seen any changes in the last few years?
Yeah, I mean, so when I started Lambda and, in 2012, like deep learning was something that you had to like tell people about and like convince them that it was a real thing. And then they go, well, but weren't neural networks already tried in the 1980s? And you're trying to go, well, no, this time's different. And you don't have like the shared language, the shared sort of like, oh, well, it's the bitter lesson, right? Which is that, compute power has been the one thing that's been driving the progress here on the same exact algorithms we've been using since the 1980s, because, you haven't spent a lot of time thinking about like the structure of how that science progresses. So you have to like convince people. And then in the early days, it was like, we were using Torch, like Lua Torch. So before it was PyTorch, it was Lua Torch. It was just called Torch. And then there was also, we used Theano, which was like a Python that was sort of like a graph. You just, it would create a computation graph. And that was sort of like a very similar to the first version of TensorFlow. It really took some time, I'd say between 2012 and when Cafe came out, started becoming really popular in 2015, 16. It was still like very early days for deep learning. And it would have been very difficult to like start a business that was providing deep learning infrastructure because there wasn't a lot of people doing it. And then I'd say, between 2016 through maybe, I'd say until now, like until like ChatGPT came out, right? And like Stable Diffusion came out, like 2016 until 2022, let's say, those 5 or 6 years are like the early adopters almost kind of thing. You're starting to see people, do AI first startups and whatever. And then now I think that we've finally started to, you basically between 2015 and 2022, people on Hacker News were really interested in learning about deep learning because they kind of saw it being the future, right? But that was only people on Hacker News who are really a let's say, technology forward group, right? And then, thankfully, we've been able to build a business around those sort of early adopters, I think. And, so we have customers. I mean, look, our customers are pretty much every company in the world. It's kind of crazy. Like, name a company, whether it's Amazon Research or Pfizer or Los Alamos National Labs or parts of the US government, parts of the US military, parts of any type of publicly traded company or, AI startups. I mean, we have a lot of different customers, and that part of the business is done really well. Like, so we have this sort of, on-prem AI infrastructure business where we have laptops, workstations, servers, and, large scale deep learning clusters called Echelon. And then we have a GPU cloud service, which, is sort of swipe your credit card, pay by the minute to run A100s in the cloud. And, our GPU cloud is about a third of the price of AWS. It's like $1.10 an hour for an A100 that otherwise on AWS would be about $4 an hour.
Is the infrastructure consumption by the Dall-E's and ChatGPTs, like, is it comparable to the infrastructure consumption of the earlier models?
I think that, again, like going back to, transformers and these large language models really have changed a lot. Most of the ConvNet models, whether it's like Resonant 52, VGG, AlexNet, these were always things that you could pretty much train on like a workstation under your desk. And generally speaking, that was the scale of training that I think a lot of people did, maybe up to an 8 GPU server. The large language models are things where you're doing multi-node training, you need high-speed interconnect. And I'd say that, the large language models have really bumped up the amount of computation required by, at least an order of magnitude, if not more. And that definitely drives a lot of the increase in computational scale. Like now it's not uncommon, right, for somebody to pitch a venture investor and say, well, we need a $10 million compute budget to, train our neural network for this thing.
How do you see Lambda continuing to evolve to hit that, right? Because the nature of the market's shifting, it's getting bigger, it's getting juicier too. You may be seeing different types of competition or different types of customers show up. How do you think about the future of your company within the space and then how it all goes forward after that?
I think one thing we've done really good job of, and it's just because, we're building for ourselves at Lambda, right? My background's doing deep learning engineering. We have a lot of people at the company whose background's doing deep learning engineering. And we've really done a good job of just focusing on building useful stuff for the deep learning engineer, right? Whether that's, we publish benchmarks of all the GPUs and their performance. Like, I think we were the first company to publish benchmarks that were measured in your stable diffusion throughput. Like, basically instead of doing it as iterations per second for training image recognition network, we're like, how many images can you generate per second with this GPU, right? And, so we just been so focused on making valuable stuff for the deep learning engineer. And I think that's been, that will continue to guide us now and, for forever, really. I mean, I don't know what else to say other than we're the company that's built around, catering to that one persona, which is the deep learning engineer. And so, yeah.
I'll try to end us with a very fuzzy question, which is going back to these science fiction stories and how some of these books, you start them and they're kind of like incomprehensible. The author's trick is to invent this world, like do all this world building with this magical technology that has all these complicated words and then build up like human society around how it uses that technology and then incorporate into the language and into like the structure of the world, the outcomes of having imbued these technologies and higher order like intelligence machines into daily life. And so you try to read this book and for the first 30 pages you're like, what do these words even mean, until you kind of absorb the language and absorb the world building and all sort of starts to make sense and you understand how you're like thrown into this native but strange environment. And I feel like we're all on a path to the same place, right? Where like right now a lot of this stuff feels like so novel and weird and deeply transformative and valuable as we race towards some sort of metaverse singularity event. But it's going to end up getting incorporated into our lives, and it's going to feel like all technology that at one point was amazing, right? Like 2007 iPhone, it's going to feel pedestrian, and we're going to be like annoyed the way that we're annoyed about how slow internet is, on an airplane, rather than being amazed that it's there. what's that science fiction worldview for these technologies once they're absorbed into our society? Like, where do you think we're going to land?
Yeah, it's actually great. So I recently watched Her. I'm sure you've seen it, the Joaquin Phoenix 2013 film. And it's funny because I watched it when I was first starting Lambda. And I thought, wow, like that's so out there. And this is a really cool film. And then now when I rewatched it, all of the stuff that's like a lot of the stuff that's predicted in it is basically already here. And it's really just a matter of like somebody needs to go and build it. And, you talk about like whether it's singularity or whatever. I've never been a really big believer in sort of AI singularity stuff. I just think it's so far away. And we still use trains for transportation. We still use trains. Trains still do 50% of the freight in the United States. And the reason I say that is sort of like a way to say that old technology and humans really don't like change. Things don't change as fast as you'd think they do. But like the point is that if you rewatch Her, and like everybody has the ability to go and take what is out there today, whether it's a large language model, a diffusion model, whatever, and build a really new experience. And I think the cool thing is that the people who are going to be defining the next 10 years, what is commonplace and what is the basic pedestrian thing that we get frustrated with, are all building those things today. And that generally speaking, just back to that Alan Kay quote, like, if you want to predict the future, invent it yourself. Everybody now with the way things are going, like you're in a great position to build that next amazing thing that doesn't exist right now. And it's kind of cool that I'm very honored to be able to have those people as customers and to be able to provide them with the infrastructure for them to build the future with.
Amazing. Great place for us to put an exclamation mark. If our listeners want to find you or to learn more about Lambda, where should they go?
You can find me on Twitter. I'm relatively active, Stephen Balavan, STEPHEN BALABAN. Our website is lambdalabs.com, LAMBDALABS.com. And so those are the two places people can find us.
Fantastic. Stephen, thank you for joining me today.
Yeah, Lex, thank you so much for having me.
Hi, everyone. That's it for this week's episode of the Fintech Blueprint. For more technical deep dives into all things fintech and decentralized finance, check out fintechblueprint.com and grab a free subscription to the newsletter. This is Lex, and I'll see you next time.